Howdy. In this video, I'm going to take a look at some relationships that are important for you to understand from the unit circle and the trig values. I'm not even going to call it a unit circle. Trig values. So if I look at the first one here, sine of pi over 4. So again, hopefully you're getting comfortable with these radian values. Here's a quick review of the 5 you really need to know. You can find them all through division if you want. 180 divided by 2 is 90, 180 divided by 4 is 45, 180 divided by 3 is 60, 180 divided by 6 is 30. That's really your call how you remember them, but important for you to be comfortable with those. So pi over 4, you're hopefully saying right away, oh, that's 45 degrees. And so I start out 0 here. Pi over 4 is going to be a fourth of pi. So this is a 45 degree angle. And so if I make a point here on the circle, and I've got a 45, 45, 90 triangle, I'm thinking 1, 1, square root of 2. So my x value is 1, my y value is 1, and my radius is square root of 2. And this is just building off of the ratios for a 45, 45, 90 triangle. We could have chosen another 45, 45, 90 triangle ratio, but this one's pretty easy to work with, especially when I'm doing sine and I want to think about the definition of sine on the circle, and I think of it as y over r. So the definition of sine on any circle is y over r. That's not just how I think of it. I like to think of it of a different circle with a radius of square root of 2, because y then is 1, and that's fairly easy to work with, and it connects well to what you learned in geometry in high school. I'm okay with you just leaving it here, or if you want to, you can rationalize it and it becomes square root of 2 over 2. So either one of these is fine. Okay. Now on the worksheet that I asked you to complete for homework, there's another problem similar to this, and I'm going to jump down to that one now, number 7. So you can see sine of 5 pi over 4 versus pi over 4. So sine of pi, 5 pi over 4, working with reference angles of 45. 5 pi over 4, 1, 2, 3, 4. 5 pi over 4 is down here. And so the question is, what are the x and y coordinates here? So the x and y coordinates here for this angle, again, I'm seeing a reference angle of 45 degrees. I'm remembering in high school geometry that a 45, 45, 90 has these ratios, 1, 1, square root of 2. And so I'm just going to make my radius be the square root of 2. And then if that's the case, my x and y coordinates here, because I'm looking in the third quadrant, x values to the left are going to be negative. So x is going to be negative 1. Y values below the x-axis are also going to be negative, so that's also negative 1. I also like to put the negatives here. And so sine then is, as we said earlier, y over r. So my final answer is negative 1 over the square root of 2. Or if you want to rationalize, it's negative square root of 2 over 2. All right. Now, you'll notice similarities here, right? Maybe I shouldn't have put it down here like that. But you could see when it was 5 pi over 4, I got negative 1 over the square root of 2. Versus here, I got positive 1 over the square root of 2. Same thing, just different absolute value, or different signs. This one's negative, this one's positive. So what happens if we go into the second quadrant? This isn't one of your homework problems, but I want you just to think about the sine of 3 pi over 4 for a minute. Hopefully you're comfortable and you're thinking, okay, that's going to be over here. So this angle is 3 pi over 4. Whew. 3 pi over 4. I want to know what the x and y coordinates are here. I've got a 45 degree angle. So I'm personally going to say, hey, let the radius be the square root of 2. You might want the radius to be 1. That's fine if you want to do it that way. So then this is 1 and this is 1. And when I think about my values, my x and y values, the x value to the left, that's going to be negative. My y value here, though, is going to be positive 1. And so this is negative 1. My ordered pair, then, is going to be negative 1 for x, 1 for y. Sine y over r, so my y value is positive 1 over the square root of 2. Okay, so pretty similar to what we just done. Let's do it again. You'll notice we've done this for the first quadrant, second quadrant, third quadrant. Now let's do it for the fourth quadrant. What angle is that going to be? Hopefully you said 7 pi over 4. You are right. Again, kind of just recreating the wheel here. 45 degrees. I'm going to let the radius equal the square root of 2 so that my x and y coordinates are 1. Although we need to think it through. X to the right is going to be a positive 1, but when I go my y value, you see my y value is going to be a negative 1 here. And so my coordinates, x is 1, y is negative 1. If I look at the sine of 7 pi over 4, we get negative 1 over the square root of 2, or if I rationalize it, I could. But what I really want to point out, and I think this is apparent to you, is that the absolute values of all of these are the same. These are all the same. Some are just negative, some are positive. So let's take a closer look at this. If we think about the definition of sine on a circle, it's y over r. Where is sine going to be positive? Where is it going to be negative? Well, if you think of points, and you think about these points here, r is always positive. So the determining factor is really y. So y is positive when I'm above the x-axis, so in quadrant 1 and quadrant 2. Y, though, is negative when I'm below. I don't think this is going to work how I want. Nope. And so that's in quadrant 3 and quadrant 4. And so sine is positive in quadrant 1 and 2. It's negative in quadrant 3 and 4. That doesn't look like a very good 3 to me. Quadrant 3 and quadrant 4. Now, you could memorize that, but as long as you know your definitions, that's pretty intuitive. Let's do the same thing for cosine here and tangent. Think about cosine theta. What's the definition? If you said x over r, you're correct. Where is cosine going to be positive? Where is it going to be negative? Well, we have a similar discussion that we just had with sine, right? Instead of sine being positive, sine is positive where the y values are positive in quadrant 1 or 2. Where is cosine going to be positive? Well, again, my radius will always be positive, so it's where the x values are positive. Where are the x values positive? Over here, right? So in quadrant 1 and 4. And it will be negative where the x values are negative on the left side. So that's quadrant 2 and 3. Okay. Now, I think that's... Let me know if you have questions on that. The last one we're going to look at is tangent theta. tangent's a little interesting. Tangent is y over x. So where is tangent positive and where is tangent negative? All right, so this is a little bit trickier. We have to think about this because here the radius was always positive, so we just focused on the numerator. But here the radius isn't always, the radius is still positive, but we're not working with it. We're working with x and y, and that is changing. And so if we look in the first quadrant and we just think about x and y, we can see x is positive and y is positive. We're to the right and we're to the left, which are both positive. So tangent is definitely positive in quadrant 1. How about quadrant 2? Well, if you look in quadrant 2, you see the x value is going to be negative. The y value, positive. So if x is negative, y is positive. That means we have a positive divided by a negative, which is a negative. So tangent ends up being negative in quadrant 2. If you think this through, you'll see, oh, well, when I have a negative divided by a negative, I get a positive. So in this third quadrant, I have negative x, negative y. Then it is positive. Tangent is positive in that third quadrant. And so if you think it through, you'll find tangent's going to be negative in quadrant 4 because we have a negative y value divided by a positive x value. There's a little trick. I don't know if I remember it off the top of my head here. If we look at where things are positive, so all trig functions are positive here. Sine is positive in the second quadrant. Tangent is positive in the third quadrant, and cosine is positive down here. And I think there's some little acronym or saying to help you remember this, but I can't think of it right now. So anyway, if you look at the initials here, all are positive in this quadrant. Sine is positive in this quadrant, tangent here, cosine here. And if you look it up online, I'm sure you'll find it. So here you go. Quick summary for this video is just recognizing how there's relationships when we have common reference angles. And those values are going to be the same depending on which quadrant we're in. Let me say it this way. The absolute values for the reference angles will be the same. You'll just have some positive, some negative, and those can be thought of using these ideas here.